Good afternoon, ladies and gentlemen. Thank you very much for taking your time out today to join us in this webinar. We appreciate your presence today. Looking into the digital workflow, normally the main issue or the main decision that we always make is like, which machine should I buy or which scanner should I use? Probably the last thing that we would think about is the milling tools. Therefore, today I'm here to share with you the benefits for the end user, especially yourself. What benefits do you get out of the milling tools when you start considering it in your workflow? Now, of course, I would like to explore with you 3 topics today in this webinar. First of all, who are we, Prima Digital, and myself, and I'll share with you also our portfolio, our tool portfolio, and finally, what people think of us, our tools in particular. First of all, Prima Digital. We are part of Prima Dental. So if you look into this history chart, if you want to trace us back, it will have to go back to 1927. So we have been in the industry for making burrs, dental burrs for a long, long time. And we started to make milling tools in end of 2016. And we launched our first product in 2018. And in 2019, Prima Digital, which is the brand name for Prima milling tool, was born. So when you look into this graph, you can see this red line coming across, and especially going upwards from 2015 onwards. Those are our volume in dental burrs. We sell a lot and we sell worldwide. We are now actually the largest dental burrs manufacturer in the world. So this is only possible because we invest, especially in technology. In 2018, we built ourselves a new factory, and in no time, the factory is actually filled. And I'm now today in the new factory. So our R&D facility, I'll show you later on when we finish this presentation, the facilities that we are in today. So this is myself, just a brief one. I completed a PhD in a UK university from the Engineering and Computer Science department. Then the very first job that I had was to lecture at the university. One of the topics that I lectured was machining. Then I left academia and joined an engineering company. If you Google Sandvik, you will find this is a massive engineering company. So there are many divisions, many companies under the headings of Sandvik. And I was there designing tools in that division. And also I joined another division designing this carbide. Now, we know carbide is a substrate of tool. Therefore, they are both related. So this knowledge has actually given me a lot of advantages joining Prima Dental. Now, when I was with Sandvik, these are the number of patents that I filed. It took quite a long time to get it granted in the US, as you can see here. So both of these patents are now granted in the US. They are mainly for milling ceramic carbon fiber for aerospace industry. So in Prima Dental, we do have the know-how, not just in dentable, but also in milling tools. Looking into our portfolio, PMMA tools, these are the tools that you can get from our product portfolio. Whatever sizes you need, we have it now. Now, all the tools are coated. As you can see on the pictures there, it looks uncoated, but they are coated tools for sure. They are silver coating. They can be used for wax. If you're milling wax, you're milling acetal, you can use them. If you're milling VisiClear, you can also use them. When I was designing these PMMA tools, I was trying to gather information from the marketplace to see what do we need to consider in this particular product. I can summarize it in 2 points. One, people say, milling PMMA is very long. The other one, people were saying that, vibration that they see when they're milling PMMA, especially in the desktop machine. We're talking about desktop machine here. So when we design this tool, we look into the first issue, which is long milling time. Milling is the operations of removing materials. So you mill, you get rid of materials, yeah? Now 3D printing is adding materials. So there are 2 completely different operations, just give you a contrast. So in order to mill fast, sometimes it's a cut fast. So we have to remove material fast. Now the way to remove fast is to rough the material out fast, yeah? So the roughing tool in here that you normally see in the marketplace is a 3 mil torque tool. And that's how we designed that 3 mil torque tool to remove material fast. Now I'll explain later on how this is achieved. And in order to address the issue of vibration, we also put into the tool, the 3mm tool, certain features that can help in the vibration, to minimize the vibrations. And also we also consider this tool is used for the desktop machine. Of course, you can use it on the large milling center, but it is designed so that it can reduce vibration in the desktop machine. So what is so special about this milling tool? Now, if you look into the tools in the marketplace, you can normally get 1 flute tool for PMMA cutting. We have 2 flute because we realized that when you put a 2 flute tool into the desktop machine, in here which says a rolling machine, you can see the vibration cease. And you compare it with 1 flute, you can see the difference yourself. And also the 2 flute tool allows you to mill faster. Now I'll explain that in a minute. We also treat our 3 flute, the tool, and also any other tools that we have for PMMA on the edge because of the vibration that we get. So we treated the edge to make sure that there's no chipping. And also put a coating on the tool for the benefits of long life. That is for the benefits of the end user. Now, we're talking about the tools being milling fast. Yeah, what does it mean? Now, suppose you go running today. Yeah, you go running. So if you want to reach a destination fast, what do? You run faster. Of course, yeah, you do. You run faster. Now, likewise, you put it into a milling tools. If you want to cut faster, what do? You feed faster. That is normally come to our mind, isn't it? The first thing you say, okay, I want to feed my tool faster. So we normally say that is a feed rate. Yeah, feed rate. Now, do you know that feed rate is actually made up of 3 elements? There are 3 elements in feed rate: the feed per foot, the spinner speed, and also the number of flutes in there. So you're looking into this simple formula in there. If says the number of flute changes from 1 to 2 flute, what happened to the table feed, or what happened to the feed rate? It decreased, right? Of course not. So anything on the right to the formula go up, the feed rate will go up. We just talk about, you know, a simple formula. So one thing that you can do to increase the cutting or to reduce the milling time is to increase the feed rate. But also there are other things that we can consider. Now, suppose we go to this example again as you're running. Yeah, running. One thing you can do in your running also that you can take a big step. For people who are tall with long leg, you can do a big step. Yeah. For people like me who are short, I can only do small step. Yeah. Maybe I can run fast, but small step. Some people can run fast, but big step, right? So put it into a milling similarly. We say milling is a material removal rate, material removal operations. Yeah, the faster you remove, which is the milling rate, the removal rate, the better it is. So if you're taking a bigger step, in engineering term, we call that as depth of cut. You can do it in horizontal direction, which is a radial depth of cut, or you can do it in vertical direction, which is axial depth of cut. Now, a bigger step that will help you to finish off your job quicker, to mill off quicker and go home faster, right? So material removal rate, there are 3 elements again. The feed rate is only one of them. I'm not sure whether you have the experience where you sort of increase your feed rate, but you look into your clock, the time is not reducing. So you're like, okay, I'm actually feeding faster, but it's not reducing because there are more than one element within material removal rate. So that's how we make use of the 3 elements to get our tools mill faster. So we look into the 3 elements, the depth of cut and also the feed rate. Now, we are not going into details of how we get these numbers, but this is how we do it so that we allow our 3mm tool to mill faster. If you are a Zahn customer, good news for you. These are already incorporated within the Zahn mill box, so you don't need to remember what it is. So if you have a mill box, a Zahn mill box, either it's older version or the newer version, you just need to click under the tool package, and at the drop down, you choose Prima tool. As simple as that. Very easy, no complication. So what do we do then to give an example of how does it, what does it mean by reducing time? So we mill some sort of bridges in here. So I use a default cutting condition, which is using our tool. So we milled it slower. and then we milled it fast also with improved cutting condition. The time is reduced by 17%. That is about 7 minutes. Now, that 7 minutes would be allowing me to mill another bridge. So that is a time saving that you have in here. So we talk about understanding your machine being important because of the vibration. So if says that I would have to design this tool for a large milling machine, for example, Haas in the US is very common, or DMG Morosiki, these machines, I would have designed the two differently, because these two will have a receipt spindle, would have a holder that you can buy, or you can choose to buy this holder with dumbbell inside, so it reduces vibration and so on and so forth. So the tool can be designed differently. But then this tool we have in mind is being used a lot in the desktop machine, so we designed it to allow less vibration in the cut. Why is vibration an important issue then? Because this is what you will see. If you take one of the two, I just take one of the two in the marketplace, milled it 4 hours, I can see chipping on the edge already because of the vibration. So milling PMMA is not easy, I must say. So we design our tools, it goes up 6 hours and it's still fine. Now I just pointing out all these are called serrations. They are not chips, they're serrations. Now serrations are proven to be good to help for saber cut and also for chip formation, so we can form smaller chip to allow better evacuation. To life, so you'll be asking, how long does it last? So when I'm using these 3 mil tools, the tools in the marketplace where we tried it 4 hours, ours will last 6 hours, and also fast milling. Now remember, these are all dry milling, so if you're using it on large milling center, if you're using coolant, it can last longer. But for dry milling, we know because of the heat, it reduces the to life. Now for a smaller tool which are not used for roughing, we notice the recommended time to life for the larger tools in the marketplace is 7.5 hours. For the smaller tool is 13 hours. Ours will last up to 40 hours. Now you'll be asking, well, the 3 mil and the 2 mil, what's the difference? Why are the time different so much? So the answer is, remember, the 3 mil tool is removing much more material as compared to all these two added up together. So tools doing a lot of work. So we get the 3 mil tool to get rid of most of the materials before the 2 mil, 1 mil, and 0.6 mil can be used. Yeah, so it's cutting faster, it's doing more job. Therefore, the life is shorter. Now, looking into our Ziconia tools, these are the tools that we have launched 2 years back. So these are the sizes you can get. For Ziconia tool, we offer both coated and uncoated. So you can choose which tools or product that you need, depending on, of course, on your volume that you are milling. I'm looking into the features. I'm just going to cover 2 features. One is precision. The other one is long lasting. Again, if you are a Zahn customer, the good news for you, drop down, click on the tool package. You can see a drop down of tools that you can choose. If you have bought coated tools, you just choose Prima Ziconia coated. If you bought uncoated tools, you choose Prima Ziconia uncoated. So it's very simple. What are the features there then for the uncoated tools? There are 3 main elements that I would like to share with you. The first one is the tool substrate. We talk about hardness. So we use a harder carbide. Now, why hardness? Because hardness is related to wear resistance. Now, if you want something to long lasting, so you choose something that's harder. For example, the hardest thing in the world is diamond. Yeah, it lasts forever. But of course, we can't choose carbide that's too hard because it's also too brittle. Just like diamond, when you knock, it will just chip. Yeah. So 30% of hardness is what we found is good for this milling of Ziconia. Then we also design a tool geometry to couple with it. So we realized a 3-foot tool is good as compared to 2-foot, as you can see in the marketplace for milling Ziconia. And we'll also look into other features such as the relief angle and so on and so forth. Now, Now that we have the tool substrate, we have the geometry, the next thing that we have to make sure is that we manufacture it to a good tolerance. We are using an ISO standard to make sure that our tool fall into those standards. It might not mean anything to you, but we actually conform ourselves to this standard. So at the end, what does this mean to you? If the tool lasts longer, if it's able to mill more accurately, it means that you have less time remilling your restorations. It also means that you have a lower cost per restoration. Looking into the precision, so we did an analysis with a university in London. So I've milled all the perform all the milling in-house. So I used 3 sets of tools. Of course, Prima tool is 1 set, and 2 others tools that I found in the marketplace. So I performed the milling, and I sent the restoration out to the university without telling them, you know, which brand are there. So they performed the analysis for us. What they do is they scanned the restorations that we knew, the Prima one, the other 2 tools, and then they compared it with the digital model. Now, the digital model is a model that I mill my restoration on, based on. So that will be our reference or our target. So the university is comparing the scan against the target. So from these images, by our naked eyes, we can judge which one's better, isn't it? So we need some sort of calculation to help us. Here is the calculation. Now, looking into the last column on the right, that is the deviation, the total volume deviation. Deviations means further away from the target. So therefore, we want a smaller value. So the smaller the value, the better it is. Yeah. So in this case, you can see the Prima tool is able to mill more disc, 9 discs, as you can see, the other one 7 each before the tool worn, and the tool is also able to mill more precisely, which means with less deviation. So if we need the number of crowns that we mill, these are the number of crowns, and this is the number that we get in a lot of flyers that you can see 29%. This is how we get the number. Also, the university also do an analysis on the inner surface. So that is actually very important because that is a fit. Now, again, we need some sort of numbers to show us what it is. Again, the lower the deviation value, the total volume deviation, the better it is. Now, again, Prima stand out in here. If we analyze it from a different angle, we can say, you know, it's 4 times better or 5 times better than the competitor. Looking into our diamond coated tools, okay, so what is good about our diamond coated tools? The first one again is the substrate. Now that I'm going to put a coating on the tool, the substrate hardness is no longer an issue. Yeah, because it's not the substrate that is doing the job. It's a coating. Yeah. Therefore, now I need to make sure that the diamond adhesion to the tool substrate is good. So not all carbide is a good friend of diamond. Yeah. So we need to choose a good carbide that can work with diamond. So that is a very important point. Otherwise, you will see tool have the diamond flecking off the tool, which I see a lot, unfortunately, in the marketplace. And the other one is we put a coating on top of the substrate. Now this coating that we use is CVD diamond coating. It's as hard as a natural diamond that you can find. And lastly, we make sure that we manufacture to a tolerance, to ISO tolerance. Now, what does this mean to you then, all this? Now, of course, for the diamond coated tools, it will last longer, much longer. It means that your cost per restoration drops significantly. So if you are having a large volume to mill day to day, a diamond coated tool would suit your digital workflow. So we wanted to know, you know, how long can this tool run? So we did a marathon. So we did a milling and milling to see, you know, how long it will last. So again, I used 3 sets of tools. Prima is one, and then 2 other competitors to perform the mill, to perform a test. So this is what I get, 33% better. I would say you can go far beyond 33. Okay, this is just a reserve number. And we said that we actually tested 3 tools, right? 3 sets of tools, but there's only 2 tools being plotted here. So one is missing. Why is that then? Because I did not finish the test. I tested the first tool, 28 crowns. I got a chip. I thought, okay, I test another one, 56. I got another chip. I was like, I'm not going to continue. I don't want any hassles on my spindle. Changing the spindle is more expensive than buying a new tools. So I think that's it. So if you do not want issue as such, Prima Digital will be your choice. So finally, look into the testimony from people. I think many of us would know Ryan Fao. He is a user of our tools. Yeah, this is what he says. We are quite pleased to hear that. He says, our tools consistently. I think that's a strong word. Outrun the other tooling that he has used, and you know that he has used a lot of tools. They have tested a lot of tools in the marketplace. Now he also mentioned about our R&D department. So we are not just a manufacturer. We also design in-house. So you can see behind me, that's the machine that we use to make our tools in R&D department. So this is just for R&D use. And we also see, you can see also all these machines I have here to analyze the tool. So the other testimony we get is from a lab owner in New York City. So I was talking to him, he was funny. I said, so tell me, how long does the tool last? He said, oh, very long. I said, how long? I said, I can't remember because keep going. But that's a good thing. So, at least 200 hours. It's good. He said, keep going. He lost count, which is interesting. It's good to hear that. So, and he was also saying that he doesn't need to change his milling per often, and he doesn't find any chipping on the margin, so that he doesn't need to remill. So I think those are great testimony for us, really. But if you're using our tools out there, tell us what do you think. Thank you very much for your time. Thank you.
Thank you so much, Dr. Goh.
Thank you.
We do have a couple of questions, so we're going to open up everything to questions now. The first one is, do I need to do anything when I have my PMMA tools?
Very good question. So if you are a Zahn customer, you don't need to do anything. Of course, you are not Zahn customer, you don't as well. Yeah. So if you buy your tools from Zahn, you just go into your mailbox, just click Prima Dental Tools, PMMA tools, then you are done.
Perfect. And the next question is, I see a lot of tools out there that are not diamond coated. Could I use those on zirconia?
Very interesting. Interesting, because there are a lot of tools out there. They are not diamond. They call themselves diamond, but they are actually it's called DLC, diamond light coating. They are not diamond. My personal advice is you either use uncoated tools or you use a diamond coated tools. Diamond coated tools, if you have a large volume to mill, use diamond coated tools. If says that you are milling, here and there, our uncoated tools is good enough, because we have a feedback from one of the lab owner. He was saying even our uncoated tools perform as good as the DLC, for example, one of the coatings. So our uncoated tools will give you more restoration, what we call cost per restoration, definitely.